So now we've got a question from the 2017 Exam 1, again a question 7. So we're getting up to the hard questions in the multiple choice. So, at a fish farm, young fish, Y, may eventually grow into juveniles, J, or they may die. Juveniles, J, may eventually grow into adults, or they may die. Adults eventually die. Okay, so the initial state of this population, F0, is shown below. So you can see this F0, this initial state, we start with 50,000 young fish, 10,000 juveniles, 7,000 adults, and no dead ones. So every month, fish are either sold or bought so that the number of young, juvenile, and adult fish in the farm remains constant. Okay, so we always want those numbers to remain constant, to be the same. The population of fish in the fish farm after n months, Fn, can be determined by the recurrence rule. So we've got it here. So we've got our transition diagram. That would be this month, next month, Y, J, A, D, Y, J, A, D. And you can see we've got this plus B here, where B is a column matrix that shows the number of young, juvenile, and adult fish bought or sold each month, and the number of dead fish that are removed. So we'll be adding fish, like young, juvenile, adult fish. We'll be either adding them into the system by buying them, or we'll be taking them out of the system by selling them. We'll also be removing the dead fish from the system as well. So each month the fish farm will. Okay, so we've got a few things there to test. What's going on? Whether we're selling or buying in various things. So really, they want us to figure out that B. They want us to look at that B. Okay, so let's have a look again at the information we've been given. So we know our initial, we know our transition. We also know that the number of young, juvenile, adult fish in the farm remains constant, so that each month they actually want that many fish in the system, okay, and that many young, juvenile, and adult fish. Okay, so that gives us our start. So I can think, well, okay, just for argument's sake, let's go and say like F1 equal to that transition matrix times by F0 plus B. Okay, now, because we get told that the number of young, juvenile, and adult fish are the same, I know that F1 must be equal to F0. So let's set this up. Let's write this up. Okay, so 50,000, 10,000, 7,000, 0 equal to our transition 0.65, 0, 0, 0 to 5, 0.75. I've not left myself much room there. 0, 0, 0, 0, 0.2, 0.95, 0, 0.1, 0.05, 0.051. Okay, times by, oh, run out of room, but 50,000. Now, we can do all of this obviously on our CAS, and we'll be doing it on our CAS, but I thought I'd write it up so you can see what's happening as well. Plus B. Okay, so that is what we are figuring out. We need to, in the end, figure out B. So let's use our CAS calculator to do this. Okay, so I'm going to do a solve. That's going to be, that might be the easiest way. Okay, there's a couple ways I could have done this. Okay, let's see how we go with the solve. Okay, so there's 4 rows, 1 column, 50, 7,000, 0 equals, now we've got our 4x4 transition matrix, 0.65, 0.25, 0.75, 0, 0. I might pause it here and put these in. Okay, so what I've done here is I've popped all of that in. And you can see I've put in Y, J, A, D, and that's what we're solving for, Y, J, A, D. Okay, so I've got them there now. A little tricky because they didn't put them in the order. So that is 1750 for Y. A is negative 1650. D is negative 5,850. And J is negative 10,000. Okay. So the other way I could have done this, is coming back here, is I could have times these two together, done that. So I'll write it here. So F1 equals transition F0 plus B, and because we're solving for B, I would take this from both sides. So F1 take away transition F0 equals to B. Okay, so let's do that on the CAS. I'll grab bits and pieces from this one. So let's select that and copy it. Okay. Control copy, paste, take away, enter. And you can see we've got the same matrix there. So young, 17,500, juvenile, negative 10,000, adult, negative 1,650, and dead, negative 5,850. Now, what does it mean if it's negative? That means it's being taken out of the system. So, literally taking out all the dead ones. These 10,000 is what you'd be selling. And here that one's positive because you've added it to the system. So that's why it's positive. You've bought them and added it to your system. So let's look at these options that we had here. So which ones make sense? So A, sell 1,650 adult fish. Yep. Because they're leaving the system. B, buy 1,750. Nope. C, sell 17,500 young fish. No, because they've been added to the system, so we've bought them. D, buy 50,000. Nope. E, buy 10,000 juvenile fish. No, because we are selling them. They're leaving the system. So the answer there is A. 36% of the state answered correctly. 24% of the state answered C. And 17% answered D. I think there they might have just misread that. So C, I can certainly understand where they look at that and go, well, I see that number there, I see it there, I'll pick that one, without understanding the difference between like selling and buying and what that means for the system. So if you get a question like this, you've really got to understand what it means when things are, if that bit of information that the fish remains constant, and what it means to the system if you're adding or subtracting things. So I'll go through a bit more of the examiner's report. Many students struggle to answer this question correctly. The critical information in the question was the fact that the number of each type of fish remains constant, so that the matrices F0 and F1 were the same. So there it goes through constructing our matrix equation, which we've done. At this stage of the solution, the question required the student to correctly interpret the signs of the elements in matrix B. A positive value means fish are added, so added to the system, bought. A negative value means fish are sold or removed. The element in the third row of this matrix show that 1,650 adult fish must be sold if the number of each fish remains constant, leading to the correct answer, option A.